Our friends at the Beyond Earth Institute are hosting their annual symposium in Washington, D.C. on November 1st and 2nd. The theme this year is LEO to Lunar to Living Beyond Earth. You can join senior leaders from across industry, government, and the international community to examine the policy challenges impacting the rapidly evolving space ecosystem. Leaders like Michelle Hanlon, Lieutenant General John Shaw, Frank White, and more. Register for the event at beyondearthsymposium.org or space.n2k.com/beyondearth. We hope to see you there. You might remember that there was a coolant leak on the ISS last December, which was believed to be caused by a micrometeorite. Well, that leak caused a 6-month delay for crew that were scheduled to return home, and that included NASA astronaut Frank Rubio, whose planned 6-month mission instead ended up lasting over a year. And this past February, the Russian Progress MS-21 cargo ship docked to the ISS also had a coolant leak. And as it's often said in the news business, 3 times makes a trend. Not a great one in this case, as there was a third coolant leak over the weekend.
T-minus 20 seconds to LOS egress. Go for deploy.
Today is October 10th, 2023. I'm Maria Varmazis, and this is T-minus. The Russian module on the ISS develops another leak. PLD Space launches Europe's first fully private rocket. ESA launches the 23rd Vega mission. And our guest today is Sascha Deri, CEO of bluShift Aerospace. Stay with us for that. And now, on to today's Intel briefing. Over the weekend, there was news of yet another coolant leak aboard the International Space Station, specifically coming from Roscosmos' Nauka module. The coolant was leaking from an exterior backup cooling system, which was added to the Nauka module this past April. The leak was pretty plainly visible as frozen flakes of coolant sprayed out into space on the ISS live cameras. Both Roscosmos and NASA investigated the incident and then confirmed that the station, and more importantly, the crew, are not in any danger. NASA's update said this: the primary radiator on Nauka is working normally, providing full cooling to the module with no impacts to the crew or to space station operations. Teams on the ground will continue to investigate the cause of the leak, and additional updates will be made as available. Europe has experienced a launch resurgence this weekend, starting with the continent's first fully private rocket. PLD Space launched its recoverable Miura-1 rocket early on Saturday from a site in southwest Spain. The Miura-1 rocket is named after a breed of fighting bull. The suborbital launch lasted just over 300 seconds and reached an apogee of 46 kilometers. Spain's acting Prime Minister Pedro Sanchez posted this on social media. The launch of the Miura-1, the first rocket with 100% Spanish technology, has been a success, a milestone that positions Spain's research and development at the forefront of space transportation. And Monday saw the European Space Agency's 23rd Vega launch. ESA announced a successful rideshare for the onboard payloads, including the Earth-observing THEOS-2 satellite and the meteorological satellite Triton. THEOS-2, which stands for Thailand Earth Observation System 2, is an observation satellite manufactured by Airbus for the Geoinformatics and Space Technology Development Agency of Thailand. THEOS-2 aims to provide the Ministry of Agriculture of Thailand with information on water resources, weather, and land use for planning and management. Triton is a Taiwan Space Agency satellite that will collect signals that bounce off the sea surface to help scientists calculate wind fields over oceans. and both satellites were released into a sun-synchronous orbit. On to some UK space economic news now from Astroscale. The space sustainability company says it has some 12,000 high-skilled, high-paid jobs across the UK, fostering innovation and expertise in the rapidly growing space industry. The company claims to deliver £23 per £1 return on public investment and says its end-of-life space service is projected to contribute £2 billion in revenue for the UK space industry over the next 10 years. And now on to some partnership announcements next, and starting with Astrobotic, who have successfully completed a flight test campaign for the University of Central Florida. The campaign consisted of 4 flights aboard Astrobotic's Zodiac vertical takeoff, vertical landing rocket to study the university's Ejecta Storm laser sensor. The laser sensor was developed to study plume surface interactions between a rocket plume and lunar regolith. The test campaign will provide valuable data for researchers as they seek to better understand plume surface interactions for humanity's return to the moon under NASA's Artemis program. The Hague Institute for Global Justice and the Global Spaceport Alliance are partnering to work on the near-term testing and operations of vehicles capable of performing point-to-point transportation through space. The 2 organizations will concentrate their efforts on developing a roadmap to address the pressing need for legal and policy frameworks. The roadmap will identify the actions required in order to allow society to benefit from the ability to transport cargo and eventually people on high-speed intercontinental flights via space. Azerbaijan has joined China's International Lunar Research Station program. Representatives of both countries' space agencies signed a joint statement of cooperation on the ILRS program during last week's 74th International Astronautical Congress held in Baku. The 2 nations plan to carry out extensive cooperation in the demonstration, implementation, operation, and application of the program, including mounting scientific instruments, providing training to personnel, and conducting scientific and technological experiments. The ILRS program, which is jointly initiated by China and Russia in 2021, aims to build a base on the moon and carry out lunar research and exploration. Indian space company Skyroot has announced a trilateral partnership with Explio Group and ConnectSat Aerospace. Explio will provide reconfigurable software for ConnectSat's IoT satellite, set to launch on Skyroot's Vikram 1 rocket. Skyroot Aerospace held its first successful suborbital launch in November last year. There's no news yet on when their next launch will occur. And our final partnership announcement for today sees another luxury brand jump on the space bandwagon. And this next one is Mercedes-Maybach, which has announced a partnership with Space Perspective to create the ultimate in luxury space travel, a high-altitude balloon experience to 100,000 feet. 8 explorers and a captain will be transported in a 6-hour flight with a meal and cocktail service. Now, it might not be the space per the U.S. standard of 50 miles above sea level, but the companies believe the apogee of 19 miles will provide the passengers with the overview effect that they're looking for. That concludes our briefing for today. You'll find links to further reading on all of the stories we've mentioned in our show notes. We've included a few extra stories for you as well, and one's on North Korea's satellite ambitions, and another on why nations are scrambling for the moon. Those stories and more are all at space.n2k.com, and just click on this episode title. Hey T-Minus crew, if you're just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. And also, if you could do us a favor, please share the intel with your friends and coworkers. Here's a little challenge for you. By Friday, please show 3 friends or coworkers this podcast. That's because a growing audience is the most important thing for us, and we would love your help as part of the T-Minus crew. If you find T-Minus useful, and as always, we really hope you do, please share it so other professionals like you can find the show. Thank you so much for your support. It means a lot to me and to all of us here at T-Minus. There's a new space hub building on the East Coast, and it may surprise you to find out where it is. Maine, yes, vacation land, Maine, is positioning itself as a new space launch and manufacturing center. Their inaugural space conference is being held November 5th through 7th in Portland, Maine, and T-Minus is going to be there. We've included a link to sign up for the event in our show notes. So I wanted to learn about the companies operating in the state of Maine, and where better to start than with bluShift. I spoke to bluShift's CEO, Sascha Deri, and started by asking him about how he came up with the idea of producing the world's first commercial rocket powered by carbon-neutral biofuel.
Yeah, so I was doing a small rocket engine test with an engineering buddy of mine from back in college and looking to develop a propulsion system that we could ultimately build a rocket company from. And we were using a petroleum-derived version of the fuel at the time. And I was on my brother's organic farm here in Maine, and just happened to come into his house just after we had done an engine test. And I noticed the substance on his windowsill he pulled off the farm like just the week prior. And it made me think, I wonder if like that substance could be used as a fuel. And even if it wasn't as high performing as the traditional rocket fuel that we're using, even if it was just a little worse, I'd be happy with it because it was far more sustainable. So we went and tested that fuel out 2 weeks later, spun it up, and it not only worked, it worked even better than we expected. Actually better than the petroleum version of the fuel. And so then it was more looking around like, why isn't anybody else doing this? And that's kind of where it all got started. Then we really honed in our go-to-market strategy over the years to come and developed our hybrid engine technology, working a lot with folks from NASA Marshall Space Flight Center who were really helpful to us in our initial goings of the company. We're about to hone in our full-size engine that will be used not only in our suborbital launch services, but hopefully in the years to come, our orbital launch services. So it's really an exciting time. It all just started from a farm, as most rocket companies should start from, I just want to say.
I just really love that. Could you tell us a little bit about your launch vehicles? Because you have done a suborbital launch.
Yeah, so we launched a prototype suborbital back in 21, and that was the very first rocket has already been launched using a bio-derived fuel that's non-toxic, and we've since then been scaling up our technology to the full. It's basically an engine that's 2 feet in diameter, puts out about 20,000 pounds of thrust peak. I'm getting a little techno nerdy here, but
That's okay.
I'm proud of those stats.
You should be.
And we call it the Marvel engines. And the Marvel engines it's kind of talk around with rocket companies. Somewhere between 60 and 80% of the effort really goes in getting a propulsion system to work right. And in our case, we're not only honing in the propulsion system, but we're honing in the fuel. So we had to really get the formulation just right, and the oxidizer to fuel ratios just right. And that's taken us quite a bit of effort. And then whenever you scale it up, that takes a lot more effort too. You go from operations where you can hand carry stuff to where everything has to be forklift around, and it's on a massive scale. But right now, we're about a month away from doing a full engine test where a full burn will allow us to qualify the engine for a complete, not only suborbital test, but suborbital to space test. Our previous prototype launch was just up over a mile. We had to shut the engines down because of FAA regulations. The next launch or two will be a full launch to space. And that's using one of our Marvel engines. And the whole way we've designed the sort of Marvel architecture is that the one engine that we use on our suborbital rocket will be the same engine we use on our orbital rocket, just more of them. So we've actually used a little bit of AI to help us figure out the optimal configuration of the staging and optimize our weight, the fuel, where we can go, how much we can carry for payload. It was actually pretty neat. It was actually kicked off by one of our interns 2 years ago.
Wow.
He really led the AI emphasis inside our company back then before it was cool. At least it was before it was cool internally. And figured out this really optimal design that reduced our engine count by half, almost half. So just like 5 years ago, we had this rocket that had 3 stages and something like, I don't think it was like 16 engines. And now we're down to 8 engines and same payload capacity, actually more payload capacity. So our whole thing is to push into not only launch these rockets using environmentally sound propellant, a propellant where if it actually went into the ocean, it would be less toxic than the boat that might be used to recover our engines and our rockets. So the whole plan is we're planning to reuse our rockets. We won't be able to reuse the second stage because that'll be long and gone, but the first stage of our orbital vehicle will be completely recovered. The rocket's still really small compared to what everybody sees on the media when they think of like SpaceX or the ultimate Blue Origin rockets or even Firefly. We're talking about something that's about 6 feet in diameter, about 65 feet tall. So really, pretty small in rocket terms, especially for orbital vehicles. And one thing that we're really proud of is that our architecture and our propellants allow it to be sort of indefinitely stored. So we can have these ready to launch our customers' payloads up into space. There's no liquid oxygen. You don't have to keep things at cryogenic states. And we've filed a patent for the technology that enables us to use these propellants. So it's not only just our fuel, but it's also how to use our oxidizer in a way that gets enough performance that we can push to orbital speeds, which is no easy task. But one of the things that makes us really unique is ultimately where we're launching from, at least initially, early days.
You've anticipated my question beautifully. Why Maine?
Our plans are to initially have launch services, regular launch services off the coast of Maine. And it certainly seems non-intuitive, Maine. And usually people, it's because it's close to the North Pole. It's like, well, we're not that far north. So it doesn't give us that much. I'm not sure what that advantage is, but we can see the northern lights sometimes. But the real advantage is actually going the other direction because Maine's coastline jets over and looks over in a south-facing way over the Atlantic Ocean. We can shoot directly over the Atlantic Ocean without going over people's properties and homes and the like. And you really can't do that anywhere on the eastern seaboard and be able to launch into an orbit that's called a polar orbit. So, people often think about launching stuff into space and they always think equatorial, isn't that somehow better? And there are advantages to that. But the whole market that we're going after is to launch these tiny satellites in space. And just over half of them want to go into this polar sun-synchronous orbit. And there's 2 places in the United States you can launch from to put these satellites directly into that orbit. One is Vandenberg, which is Air Force Base out in California. Very expensive to launch from.
A little bit busy.
And very busy. Like if you're a commercial launch vehicle, you are waiting for any DoD mission to go up before you're going up. And very, bureaucratically encumbered. And then, something similar with Kodiak Island off Alaska, also very expensive and logistically very challenging. And so our ultimate plans are to be manufacturing, launching, recovering our rockets within just a couple dozen miles of each other. And so keeping it really tight, which is concept of operations. And our manufacturing facilities will be up at the coast of Maine. The real key is that we're going to be owning our own launch site. It's going to be a sea-based launch platform, a lift boat. And by owning our own launch site and having control of our own destiny of when we can launch, we're not sharing it with other larger rockets. We're able to reduce our costs for our launching by probably 25 times versus our competition. Now, when you're a small rocket company or a small launch vehicle, you can only generate so much revenue per launch. So launch logistics becomes an incredible part of your costs. And we've figured out a way, in addition to, the fact that our propulsion technology costs about half as much to produce. We're going to be recovering our engines.
Yeah.
Our fuel technically is less expensive, but having that incredible operations cost advantage over our competition makes us really at an unfair advantage versus other small launch companies. We're really going to be honing in on launching 1 or 2, maybe 4 small satellites at once, and where others, they need the economies of scale in order to really be profitable. And I think we figured out one of the ways to launch small, individualized payloads into space where others are unable to do this in a profitable way. Right now, there's no launch company that can replace individual assets. You're not going to send up a small satellite and be dropped off wherever the SpaceX is going. What you want to do is you want to replace that single asset that these satellites last up in orbit maybe 3, 5, 6, 7 years, and then they naturally come down. And so we're going to be that company that can replace individual satellites where others can't. This is a really crude metaphor, but I think it's really appropriate. we're like the pothole fillers of space. So,
as a Massachusetts native, I'm very sensitive to that
about
idea.
potholes. Yeah.
Like,
So there's that.
what's that? A filled pothole? What does that look like? I've never experienced that in my life. All right,
The least sexiest pitch line you can have, right?
It's evocative, though. I understand the idea. Like there's a gap, and then you go in with precision, and you're able to fill it, as opposed to like sort of a spray and pray or sort of a large blast radius.
You have the large contractors who deploy like the pavement, which is like the constellations initially, but then you have the smaller contractors that come into it that you have forever. You always need maintenance on those constellations to replace individual satellites. And nobody's really cost effectively doing that today. And we will be able to.
We'll be right back. Welcome back. To quote David Bowie, is there life on Mars? Well, we're not here to make some bold announcement about a new discovery, but rather to expand on the question. If humans can create a habitat on Mars, what would that life on Mars be like? Now, there have been, and there are, many Mars habitation simulations here on Earth to see what kinds of challenges life on Mars could present to humans. And many of them have been multi-week or multi-month affairs, which is quite a commitment. So if you'd like to get just a taste of life on Mars, though without quitting your day job, how does a 3-day simulation sound? Doable? Well, there is one that will be running in January 2024 in southern Florida. It's called, quite simply, the Life on Mars Challenge. And the goal is to simulate what it would be like to be an astronaut on Mars, with participants working on 6 different teams to solve challenges related to creating a community on Mars. And the 6 teams will be operating in human services and recreation, health and safety, structure and suit design, habitat operations, resources development and management, and nutrition and agriculture. This Life on Mars Challenge is a cooperation between the Alan B. Levin NSU Broward Center of Innovation and the Space Foundation. So if you're thinking 3 days in a Mars habitation sim sounds like a good time, the program is open for applicants right now through October 27th, and there's even a virtual application sesh happening October 20th if you want to get more information. We've got links for you in our show notes if you'd like to learn more or apply. And if you get in, definitely get in touch with us and let us know, because we'd love to chat with you about your experience. That's it for T- for October 10th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our Chief Intelligence Officer is Eric Tillman. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.
T-.